Moving on, there's one final way that we want to classify different variables. In particular, we typically distinguish with the precision by which we're measuring these variables. Now, this is different than a continuous or discrete distinction. In fact, the different measurement scales, the way that variables are classified according to this, are not completely independent of discrete versus continuous. But, for example, you might have a discrete variable that exists on different measurement scales, and or a continuous variable that exists on different measurement scales as well. So what are these four different measurement scales? I think you've probably seen these in the past, but we're going to cover them again here quickly, and these are also again covered by Jackson in Chapter 3. The first is what we call a nominal scale. In this case, numbers are used only as labels if they're used at all. So either words are used. Gender is the typical and probably most common nominal scale used in psychology, male and female. Now when we're doing statistical analyses, we might assign a 1 or a 2 or a 0 or a 1 to male and female. But in this case, the numbers are used only as labels. They don't mean anything more than that. The second type of scale, and these are ordered in terms of increasing precision. So in ordinal scale, not only do numbers identify different quantities, okay, but they're also used to be able to rank or order. Okay? In other words, if we have an ordinal scale, then we know that 3 is greater than or less than 2. Okay? 5 is greater than or less than 4, and so forth and so on. So we can use the numbers to rank or order things, but there's no meaning of value differences. In other words, we don't know that the difference between 2 and 3 is the same as the difference between 3 and 4, or between 4 and 5. So any sort of ranking scale is going to exist on an ordinal scale. If we look at the U.S. News and World Report, top 200 colleges and universities, there are going to be numbers attached to those universities that are used to rank or order them. Number 1 being the best, presumably, according to their methodology at least, number 2 being second best, and so forth and so on. But there's nothing that we know that says that number 1, the difference between number 1 and number 2, is the same as the difference between number 2 and number 3, or between number 102 and 103. Okay? There's not necessarily a difference in the scoring mechanism that U.S. News and World Report has used that says that there's a consistent difference between any 2 points on this scale. Now, if there is a consistent difference between 2 points on the scale, then we move up in precision to what we call an interval scale. So now the numbers convey value in the sense that equal intervals between these values represent indeed equal differences. Okay? However, one thing an interval scale doesn't have is a true 0 point. Okay? This is something that Jackson talks about in a little bit more detail, so I'll leave it up to her for you guys to read there. Okay, but what this true 0 point does is it also makes additional operations meaningful, like double and half. So on an interval scale, doubling values doesn't necessarily double the amount or the quantity that they represent. Okay, the most common example of an interval scale is that of Fahrenheit or even Celsius measurement of temperature. Okay, so when it's 80 degrees outside, that doesn't necessarily mean that it's twice as hot as 40 degrees. And 160 isn't twice as hot as 80 degrees. Okay? But a move from 80 to 85 degrees does mean the same thing as a move from 100 to 105 degrees, or 40 to 45 degrees. So in other words, the difference between any 2 points on the scale, in other words, a 5-point difference, means the same thing no matter where on the scale it's occurring, whether it's from 40 to 45 or 100 to 105. So it would be an interval scale, but because there's no true 0 point, 0 degrees Fahrenheit isn't 0 of anything. It doesn't mean the complete absence of heat or anything else. So because there's no true 0 point, we also can't use operations, like I said, of double, half, triple, or anything else, multiplication and division. If a scale does contain those final properties, the true 0 point, that is, where 0 means the absence of whatever it is you're measuring, the true absence of whatever it is you're measuring, which therefore makes operations like double and triple meaningful, then you're on the most precise type of measurement scale, which is called a ratio scale. So one way to think about what type of measurement scale that you're on is to ask yourself which of these things are going to be meaningful. In other words, are the numbers used just as labels that we can't even rank order them? Are the numbers to be used for ranking, but the difference between the values doesn't mean anything? That would be moving up to an ordinal scale. Or do the differences between values indeed mean something, which would put us on an interval scale? And then finally, the key question to ask yourself is 10 on this scale double whatever 5 is? Do we have twice as much of whatever 5 is if we have a 10, for example? Or any other two values that make sense on the scale. Again, maybe the best way to think about these is with some examples. And Jackson again provides a number of these as well. So if you look at the table that she has on page 62 in chapter 3, okay, she talks specifically about the mathematical operations that we talked about, the properties of identity and magnitude, and she also gives some examples of these things as well. So if you think about the research examples that we gave earlier, we mentioned political party. What type of measurement scale does political party exist on? It's a nominal scale. We can identify somebody as Democrat, Independent, Republican, and in an analysis, or if we're coding it in statistical software or Excel, we might use a 1 to represent Democrats, a 2 to represent Republicans. Okay, but those numbers, if we attach them at all, don't mean anything. They don't actually have any sort of value. You might argue differently depending on your political leaning, but in this case, political party is indeed represented on a nominal scale. What about confidence? We said it was going to be rated on a scale of 1 to 10, where 1 means not at all confident and 10 means very, very confident. What type of measurement scale would this be? This would be an interval scale. In just about any type of rating system that we use, strongly disagree to strongly agree, very much like me, not at all like me, and a lot of the scales that you might have seen on the survey that you looked at to begin class last week, any sort of rating like these, we typically assume are on an interval scale. Now, why do we assume that? Well, first of all, a confidence rating of 10, you assume it means more than a confidence rating of 9, which means more confidence than 8, and so forth and so on. Well, there we know it's at least an ordinal scale, because the order that those numbers come in means something to us. We also typically assume that the difference between any 2 points on the scale is the same. For example, the difference between strongly agree and agree is the same as the difference between strongly disagree and disagree. In fact, you'd think the adjective strongly or the adverb strongly means the same thing in both those cases. Similarly, on a confidence scale, rating from 1 to 10, we would assume that the difference between a 3 and a 4 is the same as the difference between a 9 and a 10. And any other sort of rating scale, attractiveness or anything else that you might use, is typically assumed to be an interval scale. What about reaction time? We talked about this one as well. Reaction time is a classic measure that exists on a ratio scale. So think about it. If somebody responds after 1,000 milliseconds or 1 second, that person took twice as long as somebody who responded after 500 milliseconds. Now notice I said twice as long, okay? That is exactly the type of relationship that we talked about is only possible on a ratio scale. And furthermore, what does 0 milliseconds mean? Even though it's physically impossible for somebody to give you a value of 0 milliseconds or to respond literally instantaneously, 0 does actually mean something in this case. It means that no time has passed. So this is an important point, that the true 0 point doesn't even have to be a response that's physically possible by anybody in your study. As long as that 0 point exists, then you can argue something is on a ratio scale. What about the number of errors that the people made in the driving simulator? What type of scale would this be measured on? Nominal, ordinal, interval, or ratio? This one's also going to be on a ratio scale. It's a ratio scale because, again, if somebody made 10 errors, they made twice as many errors as somebody who made 5. Somebody who made 8 errors made 2 more than somebody with 6, twice as many as somebody who made 4, half as many as somebody who made 16, and so forth and so on. And 0 really does mean 0 on this scale. Somebody who made 0 errors had an absence, a true absence of mistakes or error on this task. Okay, let's think about another one. Example. What about song position on the Billboard chart? What type of scale would this be? Like any other ranking, this is an ordinal scale. So you can say that, at least according to the quote experts at Billboard, song number 1 is better in some sense than song number 2. That is, it's more popular, has more airplay, whatever the case may be, than number 2, and that number 2 is in that sense better or more popular than number 3, and so forth and so on. But that doesn't necessarily mean that the difference between number 1 and number 2 in minutes of airplay or number of record sales or any other factor is the same as the difference between number 2 and number 3, or number 150 and number 151. Okay, the difference in record sales is not arguably going to be consistent between every single consecutive pair of songs on the Billboard chart, and neither is the amount of airplay or anything else. That is, because those differences are not consistent, you couldn't call this an interval scale. It rests only at the ordinal level.